So in another example of applying the product rule, we're asked to find the derivative given that there is a function g of x, and they give us both the function g of 4 is equal to 2 and g prime of 4 is equal to 3. Then they ask us to find the function f prime of 4. So let's break this up into pieces. I know the text actually goes through this all at one swipe, so let's just see if we can take the derivative first of f of x is equal to the square root of x times the function g of x. So we'll start with that, and we'll go ahead and follow that it is f prime of x. And when we multiply two different functions, we're going to say that square root of x is the first function, and of course g of x would be the second function. So we want to make sure that we set this up that it is the first multiplied by the derivative of the second. And then we're going to add the second multiplied by the derivative of the first. And instead of square root of x, I'm going to write that as a power. So we will have x to the 1/2. And I always like to just put my parentheses around these sets. In this case, it's not truly necessary, but just a good habit. So I'll bring down my square root of x times, well, the derivative d with respect to x of g of x, there's another way that we can write that. We can write that as g prime of x. And then we are adding just the function g of x times, and here we actually get to do a derivative. So we have the derivative of x to the 1/2. So we are going to multiply x to the 1/2 by the power. In other words, we're going to bring 1/2 to the front multiplied by x to the 1/2 minus 1. That should be negative 1/2, and we find that by taking 1/2 minus 1. Well, and Cornell has a great discussion in D2L about how to do this quickly. Whatever the power is, if it's a fraction, look at the denominator and then subtract by that denominator over itself, and you end up with negative 1/2. Now we can further combine or at least clean this up, especially this right side. So we can clean that up by stating that, well, g of x is in the numerator. So we'd have g of x multiplied by, well, it's multiplied by 1/2 times x to the negative 1/2. Well, really what that's saying is it's 1/2 times x to the 1/2. Once it's in the denominator, it's now a positive power. And we can further clean that up by saying that that's really just 2 times the square root of x. And that further means that we can simply multiply the numerators. So we have g of x times 1. And this just becomes g of x divided by 2 times the square root of x. So from this point, we really don't need to do a whole lot more with it. I would say that at this point, we could just go ahead and start solving this second portion. It says that where the function where g of 4 equals 2, so in other words, we're going to input 4 into the regular function. So I'm going to start a new line here, and we will have the square root of x times g prime, and I'll leave that open, plus g, we'll go ahead and put 4 in here, So g prime of 4 plus g of 4, and we will divide that by 2 times the square root of x. And it gives us the values. So it tells us that g of 4 is 2 and that g prime of 4 is 3. So now we can rewrite this again as the square root of x. So g prime of 4 is 3, so it's times 3, plus g of 4, well, they told us that's 2, so we have plus 2 divided by 2 times the square root of x. And of course, this will reduce to simply 1 over the square root of x. Let's go ahead and rewrite this. We will now have, I'm just going to move the 3 in front of the square root there to say 3 times the square root of x plus 1 divided by the square root of x. So now we have a function that we can work with to solve this final question, which is what or find f prime of 4. So using what we just created, I'll bring this up to the top right, and we're going to have f prime of x to begin with. And I'll rewrite it, which is 3 times the square root of x plus 1 divided by the square root of x. And now we'll go ahead and say f prime of 4, which is equal to 3 times the square root of 4 plus 1 divided by the square root of 4. And square root of 4 is 2. 2 times 3 is 6 plus 1/2. So we have, and at this point, I'm not sure if you realize this, but we could simply say that 6 plus 1/2 is just simply 6.5. If you need to, we can make the denominators equal. And to do that, of course, this 6 over 1 needs to be over 2, or base 2. So we're going to have 12 over 2 plus 1/2. And that gives us 13 over 2, which is also 6.5. So I hope that helps. Thanks for watching.